So we're going to talk about how 3rd and 4th grade math leads into today's polynomial long division. Inside I have 2671. Outside is a 3. How do we do long division? We ask ourselves, does 3 divide into 2? No, 3 is greater than 2. I'm going to put a 0 up top. Then I'm going to multiply, and then I'm going to change the sign on the second level, and I'm going to combine. I bring down the next number. Does 3 fit into 26? Not evenly, but I want to select a value that does not go above 26, so I'm going to select 8. 3 times 8 is 24. I change the sign on the second level. I combine, and this value always has to be less than the number up above. And I bring down the next number. Does 3 go into 27? It does go in 9 times evenly. 3 times 9 is 27. I change the sign on the second level. I combine down, and I bring down the last number. Does 3 fit into 1? It does not fit in, so I put a 0 up top. I multiply, I change the sign, and I combine. And then in elementary school, you may have remembered putting like an R1, or you may have written 390, and then we have and 1/3. These are both great, but how does that lead into what you're going to do? We are going to take those concepts of long division in 3rd or 4th grade, and now we're going to involve polynomial long division. So long division that incorporates variables. When I look at this particular problem, I have 3 different columns. This column will only contain x squareds, x's, and constants with no x's. So how do I decide what goes up at top? These are going to be the algorithm or the steps necessary in order to divide this. What I'm going to start with right now is I'm going to underline the x outside, and you're just watching. So if you are live with me, you're writing this down, and then you're just watching. I start with the value outside, and I ask myself, x times what? I want to fill this in. X times what equals x squared? X times what equals x squared? And the answer is x. This is my selected value. This is step 1. So up here, I can see x's are only in the middle. So I put down an x. I've selected the value. Now I'm going to multiply. X times x is x squared. X times positive 2 is positive 2x. I've multiplied. I'm going to change the sign, and it's only ever in the second row. So here's my second row, and I'm going to change the sign. So it was positive, make it negative. It was positive, make it negative. The 4th step is I'm going to combine. Positive x squared and negative x squared are additive inverses. They cancel out. Negative 11x and negative 2x is negative 13x. And then I bring down the next number. And I start the whole process over again. I have an x. X times what is negative 13x? X times what value is negative 13x? The answer is negative 13. I selected the value and put it in the correct column up above. And now I'm going to multiply. Negative 13 times x is negative 13x. Negative 13 times positive 2 is negative 26. I'm going to now change the signs. It was negative, make it positive. It was negative, make it positive. Now I'm going to combine down. These are going to cancel out, and when I add these together, I'm left with 56. Today we're going to learn how this is going to help us to identify what's called that slant or oblique asymptote. And today we do not care about a remainder. We're not going to do R56 or this amount plus 56 over x plus 2. This is what's going to matter today, and we're going to talk about what does that look like on a graph and how does it help us in graphing a specific type of rational function. The first problem today, we're going to take this new skill and apply it as we accurately sketch the graph of this rational function. And here are the things that we're going to have to identify. So let's start. The very first thing we always do is, if possible, we're going to factor this. So what multiplies to equal negative 2 and combines to equal positive 1? That's going to be a 2 and a 1. They have to be different signs. A positive 2 and a negative 1. It multiplies to equal negative 2 and it combines to give us 1. So I'm going to rewrite this as in the numerator x plus 2 and x minus 1 over x plus 3. Then I analyze. There is no factor in the numerator that's identical to the denominator, so we can't, as you like to say, cancel out. Really, it's simplifying. That's not possible. Let's go ahead and let's start identifying this. Okay, the vertical asymptote always comes from the denominator. So if I take x plus 3 and I set it equal to 0, and I solve, I get an equation of x equals negative 3. That will have to be evident on my graph. When I look up above, I see we have a degree 2 in the numerator and a degree 1 in the denominator. 2 is greater than 1. What does that mean? When 2 is greater than 1, there is no horizontal asymptote. When there's no horizontal asymptote, there will be a slant. When there's no horizontal, there will be a slant. Now, if there's a horizontal, there would not be a slant. So these are it's either horizontal or slant, one or the other. Okay, how do we determine the equation of the slant asymptote? With me, please write down the numerator inside the division box. The denominator will go on the outside to the right. And we're going to underline the first term on the inside and the first term on the outside. Okay, here we go. X times what quantity equals x squared? And the answer is x. So x is right. If you want to make these little dotted lines because it helps keep things organized, that's optional. I like x. X is correct. So above here, I'm going to write x. And now I'm going to multiply. So multiply to get x squared and multiply to get 3x. The next step, if you're looking on the board or on your whiteboard, we selected the value, we multiplied. Now we're going to change the sign on the second level, or the second row, and then we're going to combine. X squared and negative x squared will be eliminated. They're additive inverses. Positive 1x and negative 3x is a negative 2x. And then I bring down the last value. Okay, so I have an x. X times what is negative 2x? The answer is negative 2. So this is the value that goes up top. Okay, I've selected the value. Now it's time to multiply. Multiply to equal negative 2. Multiply to equal negative 6. I'm going to change the sign on the second row. And then I'm going to combine down. Additive inverses and a 4. We do not care about the remainder, so cross out the remainder. What we care about, did I make a mistake?
How do you get negative 3x?
How did I get a negative 3x here? I went x times x is x squared, x times 3 is 3x. It was a positive 3x. And remember, if you look on the board, the third step is to change the sign of everything on the second row. So this was positive, make it negative. This was positive, make it negative. Is that good, Jill? Okay. So we do not care about the remainder. This is what we care about. Here's the equation of the slant asymptote. Y equals x minus 2. How do we determine x-intercepts? In factored form, the x-intercepts always come from the numerator, just like vertical asymptotes come from the denominator. So I'm going to set each one of these quantities equal to 0, and I'm going to solve. So x plus 2 equals 0, and x minus 1 equals 0. And in doing so, I have an x-intercept of negative 2 and another x-intercept of positive 1. How do we determine the y-intercept? For the y-intercept, x is always 0. So when I look back up at this original form, this is 0, this is 0, and this is 0. And I'm left with, when I eliminate any term that has an x, I'm left with a negative 2/3. The y-intercept is negative 2/3. It's now time to start graphing, and then we have to see what type of critical points are necessary. So I'm going to come down below, and I'm going to use the information I have. I have to go to where x equals negative 3 and identify that we have a vertical asymptote. We do not have a horizontal asymptote, but I have a slant asymptote at x minus 2. Y equals x minus 2. How do I graph y equals x minus 2? I start at negative 2. And from negative 2, again, this is y equals x minus 2. I start at negative 2, and then it has a slope of 1 over 1. So up 1 and right 1. Up 1, right 1. Make sure you're as neat as possible here. Now, this is difficult for you to see. I'm going to use a pencil here, and I want you to be able to see how I am identifying. In this particular graph, there's 4 different regions. Please don't do this on your graph. This is one region. If you can see this, this is one region right here. And then here's a second region. When we graph this rational function in this form, likely it will either go into these two parts of the V, or it will go opposite into these other two types of the V over here. So how do we determine which part? Is it going to be in these two parts, or is it going to be in the side two? We use our points. We have x-intercepts at -2 and 1, so I'm going to graph at -2 and 1. Here's -2, and here's +1. We have a y-intercept of -2/3. We must graph a minimum of 2 points. They're called critical points. 2 points to the right of the vertical asymptote and 2 points to the left. I already have 3 points, 1, 2, 3. That's enough to the right, so I can graph this. Comes down and back up. I know it's going to be down here. These are always going to be opposite or diagonal of one another, okay? So I know it's going to be down here, but I need to have 2 critical points. So to find those critical points, this is at -3. I'm going to check -4 and -5 because I need 2 additional points to the right. Now, how do I determine the output values? Well, I'm going to go back up to this original equation here, and I'm now going to substitute in a -4. Please watch. Using mental math, -4 plus 2 is -2. -4 minus 1 is -5. -4 plus 3 is -1. I have 3 negatives when I'm multiplying. That's an odd number of negatives, which makes this output negative. 2 times 5 is 10. 10 divided by 1 is 10. So I want to graph the point -4, 10. -4, 10. Going over to -4 and all the way down here to -10. I'm going to do the same thing to figure out the output value when x is -5. Yes? So -2 times -5 is +10, but then +10 divided by 1. That's okay. Let's do -5 now. -5 plus 2 is -3. -5 minus 1 is -6. -5 plus 3 is -2. We have an odd number of negatives when we're multiplying. My final answer will be negative. 3 times 6 is 18. 18 divided by 2 is 9. So I'm going to go to -5 and down to -9. I have 2 critical points. It tells me it's coming up here and then back over. This is the last example in this video. We're going to factor this first. 1 times -6 is -6. We're asking ourselves what 2 values multiplied to equal -6 and combined to give us -1. -3 and +2, they multiply and they combine. So I'm going to rewrite this as h of x equals x minus 3, x plus 2 over x minus 1. We will learn the importance of factoring first, because then we're going to analyze and ask ourselves, is there any factor in the denominator that's identical in the numerator? There's not, but eventually there will be. Okay, so next we're going to go back to finding the horizontal or the vertical asymptotes. That's one of the things we have to do. Okay, you ready? Let's start with the vertical asymptote. We take, because we see a variable in the denominator, I'm going to take x minus 1, set it equal to 0, and when I solve, I get the equation x equals 1. Horizontal asymptote, we have a degree 2 in the numerator, a degree 1 in the denominator. Because the numerator is greater than the denominator, there will be no horizontal asymptotes. Don't write 0. We would assume you thought the horizontal asymptote was a 0 then, okay? So there is no horizontal, but when there's no horizontal, there will always be what's called a slant or an oblique asymptote. Now, how do we identify that? We take the numerator and put it inside, and take the denominator and write it on the outside. And we're going to follow the steps that you see on the board, which is select the value, multiply, change the sign in the second row, combine, and then bring down the next number. All right, let's slow it down. I have an x. X times what value equals x squared? Somebody can shout it out? X. X times x is x squared. So above the -1x, I'm going to write an x. Second step is going to be to multiply. X times x is x squared. X times -1 is -1x. Okay, so I've done step 1 and step 2. Step 3 says change the sign on the second row. Change and change. And then step 4 says combine. Well, these are additive inverses. They cancel out. These are additive inverses. They cancel out. So I'm left with 0, and the last step says bring down the next number. So I have an x. X times what equals negative 6? Is there anything you can take times x and get a negative 6? There's not. So let's put a 0 up here. There's nothing we can do. So this is my remainder. My remainder is negative 6, but we don't care about remainders. What we care about is what do I have on top. That's going to determine the equation of the slant, or also known as the oblique asymptote. So the slant asymptote is y equals x plus 0, or 1 over 1x plus 0. Okay, let's go back and let's identify right now the x-intercepts. The x-intercepts will always come in factored form from the numerator. So I have an x-intercept of positive 3 and an x-intercept of negative 2. The y-intercepts will come when you set x equal to 0. I like this original form, and so this would be 0, this would be 0, and this would be 0. And I'm left with y equals negative 6 over negative 1, which simplifies to just 6. Now we may have to do other critical points. I'm not sure. Let's start by drawing our graph. So I have a vertical asymptote at x equals 1. And I have a slant or oblique asymptote at y equals x plus 0. I start at 0, and I go up 1 and over 1, up 1 over 1, up 1 over 1. And so just to make a little bit of prediction here, I will either have a graph in these two areas or these two. I don't know yet, but I know it's either these two or opposite of these two. Let's graph our next points. We have x-intercepts at 3 and at negative 2. So I already know I have points here. Remember, I need to have 2 critical points to the left of the vertical asymptote and a minimum of 2 to the right. I already have 1 on each side. We have a y-intercept of 6. Okay, I have 2 critical points to the left of this vertical asymptote. That's enough for me to go ahead and graph to the left. I still need 1 more critical point to the right. So what point? That's totally up to you. I know I'm not going to check 1, 2, 3, 4 because I already know it's 4, 0. Did I graph this wrong? It should have been 3, 0, right? My fault. Should have been 3, 0. 1, 2, 3. Should have been right here. Okay, so I'm going to check 2. So how do I check without a calculator? I'm going to go back up to this form. I'm going to substitute 2 in for those x's. So 2 minus 3 is negative 1. 2 plus 2 is 4. 2 minus 1 is 1. When I'm multiplying, I have only one negative. An odd number of negatives results in a negative answer. Negative 1 times 4 is negative 4. Negative 4 divided by 1 again is this negative 4. So I'm going to go over to 2 and down to 4. And that's enough for me to see the main shape of this graph.